Okay, this one here, it's titled Power Series. It's not you're not going to see that title of Power Series when you're doing your AP test. The big thing you're going to see that goes along with this lesson, well, there's a couple big things. One of them comes in back here where it's asking what the radius of convergence is. So you'll learn how to do that in this lesson. And it's not, like, this stuff isn't anything that's, like, crazy new or crazy difficult if you know your tests. So if you did fine up until this point, you did good on 11.7, you'll do good on this one here. You just have to obviously know how to start these problems. So a power series, this is what a power series is. It's a constant, and then you have a constant x to the first plus a constant x to the second. What do you notice about the back of this here? It's going on forever, right? So this is a series where it goes to infinity type of a thing. So those terms would continue going on. It can also look like this here where it's not centered at 0, 0, but that stuff's kind of just in there because it's called power series. What we're going to do here is we're going to use a test. So what test do you think you might use for this? Ratio. You're going to use the ratio test all of the time to start these type of problems. So the ratio test, we need to, let's just write that down to start with here. We need to find what our a sub n is, which is just what's in there. So n factorial x to the n, and then you need your n plus 1 term. So instead of n factorial, we have n plus 1 factorial, and then x to the n plus 1. And are we getting pretty good with that test, breaking things down? So what do we do next with the test? Okay, so we're going to take the limit of that, right? Whether you write the limit right away or not is up to you. So we do the n plus 1 stuff first. So how can I break down the n plus 1 factorial? N plus 1 times n factorial. So I'm just going to do that as we go here instead of doing an extra step. So the x to the n plus 1 turns into x to the n times x. And then we divide that by this one here. You do want to show some work, but this is fine. We've got all of our stuff shown without having to do the extra step in there. And then we can cancel out. And if you're not using sound effects, you're not doing that correctly, right? Yep, that was good. Yeah. Okay, what do you notice about this? So we want this to be convergent. What would have to be true for that to be convergent? It has to be less than 1. If it equals 1, it's inconclusive. If it's greater than 1, it diverges, right? So this has to be less than 1. So looking at this piece here without the x, kind of ignore the x for the moment, what's this going to go to? Infinity, unless x is equal to what? If x equals 0, it doesn't matter how big n is, wouldn't it be 0? Right? It's not approaching 0. If x equals 0, this would be 0. So let's write one more step here so you can follow it in your notes a little bit better. So all I have left is the n plus 1, and then the x is still an absolute value. Okay, the n plus 1 you could take out because it's getting larger to infinity. We want that to be less than 1 so that it's convergent. So it's only convergent when x is equal to 0. Any other value of x, wouldn't this have to go to infinity? Okay, that's not the typical case, but it obviously could happen there. Let's go to the next page here. Start the ratio test on the left-hand side. And with this one, instead of dividing, I multiply by the reciprocal. So I'm just going to start that work. Let me know if you have questions here. Okay, and then we get our sound effects out. We got this one here. Gone. Okay, the x part stays in the absolute value. The part with the ends is what we're going to take to infinity. So if I take that to infinity, the n over n plus 1, what's that going to go to, that part of it? That's going to go to 1, right? So you should identify that that's equal to 1. So we just have the absolute value of x minus 3 has to be less than 1. Okay, and this might take some thinking at this point in time because maybe we haven't done it in a while. But if we know the absolute value is less than 1, that means what's inside the absolute value has to be between -1 and 1. Okay, so -1. So just squeeze it in between those two like that. And this is what you're going to do all of the time. So it's not going to be something that'll be hard to remember. Okay, so if the absolute value is less than 1, then squeeze it between -1 and 1. And then if I get x by itself, how would I do that? Add 3. So you just add 3 to each of these pieces here, and you get 2 is less than x is less than 4. Does that look okay to everyone? Okay, so we get the absolute value of x minus 3 is less than 1. Put it between -1 and 1, and then we want to get x by itself, so we add 3 to all the pieces, so we're to here. Does anyone have questions to that point? Okay, now this is like the first step, okay? We have more steps to go. The answers on the AP test will be like A, 2 is less than x is less than 4. And you're like, oh, that looks good. And then you look at B, and B says 2 is less than or equal to x is less than 4. And you go, well, that could be true. Then you look at C, and it's like 2 is less than x is less than or equal to 4. You're like, okay, that could be true. And then D has both of them equal. And then E could say something like all real numbers is typically what the last one says, because that actually could happen too. We'll see an example of that. So yeah, you have to, so we know when we get to this part here that the answer is not going to be E, right? Because it's not all real numbers, it has to be between 2 and 4. So we have to test the endpoints. So to test the endpoints, let's say I'm going to test 2. So let's start with that. Test x equals 2. We want to see if x equals 2 converges or diverges. So go back to the original. If I plug 2 in for x, what is this going to turn into?
1 over n to the, or 1 to the n over n.
Okay, this though will turn into -1, right?
Oh, negative. Yeah.
So we'll have negative, yeah. So we have -1 to the n over n. So you guys can use any of the tests that you know. The other one's a lot easier, so let's do the other one first. Okay, so here we're going to test x equals 4. So if we test 4, what's that going to turn into?
1 to the n over n.
Which is just 1 over n, right? So what is 1 over n? Okay, so this one we know is going to be divergent because it's a p-series, right? With these, they're going to be multiple choice, so you're not going to have to write like what test you use. So I'm just going to write diverge. But you can obviously say it's a p-series, p equals 1, right? So if 4 diverges, do we include it or do we not include it?
Not.
We don't include it. So if you go over here, can't we cross off these ones now? Okay, now go ahead and do this one. So I'll give you a minute or two to see if you can figure that one out. And then determine which answer would be your correct answer there then. Oh, I gotcha. Yeah, the answer's over here. So here, do you guys do alternating series test? And it worked out fine, right? Both of the pieces worked, so then you know it's convergent. And obviously show as much work as you need for yourself. So if this one converges, then you're going to include it. So then this is your answer here. So if we were choosing, we go over and choose B, obviously. Okay? So any questions on that? Yeah, I know. Now, if your answers are like what I had over there for A, B, C, D, and E, some people get tempted then to say, okay, I'm going to just assume it's 2 to 4 and then test the endpoints. And that's okay. I mean, you can skip this step if you want to and test your endpoints. But if both of them end up working, couldn't it technically be all real numbers? So if both endpoints work, then you would have to go back to check to see if it's all real numbers or if it's this. So if it's all real numbers, it's quicker to do this first because it just gives you it's all real numbers and you're not having to do your tests. But if you feel like you're going to have to do your tests anyways, you can do it the opposite way. It's kind of up to you. And it depends on what the answer is, which method is quicker. So can you try what? You could try another one if you wanted to, but the ratio test is actually really quick. This example over here, you'll see what I'm talking about. So it says here, find the domain defined by this. So that looks insane. What do you think we might use on that? We're going to use the ratio test, okay? So let's use the ratio test. Yeah, it's actually really fun. So go ahead and get started on it. No, it doesn't take a crazy amount here. Seems like it would, but. Now, if you do this problem in front of your parents, you know, like at the kitchen table while you're talking nicely to them, like you might get a later curfew because this is like, it looks impressive and it's not. And it's not that hard. You don't have a curfew? The squared piece? Yeah, you just would have 2 of them. You know what I mean?
See, I was better than my brother all throughout my life, so I get more privileges than he did.
Ah, I gotcha. I'm going to try to break some of this stuff up. Can I cancel the -1 pieces anyways? Because they're inside the absolute value. So if you want to write them down, that's fine, but I'm just going to ignore the -1 pieces. This turns into x to the 2n times x squared, right? So I'm going to write it that way. Let me know if I do something wrong. And this piece here would turn into 2 to the 2n, which you could write as 4 to the n if you want to, but there's no point because it'll cancel with that. And then times 2 to the 2nd, right? So 4. And then this is the piece that might look confusing here. It's just squared. Ignore the squared and write it down and then write it down again. That might make it easier. Okay, so n plus 1 factorial is n plus 1 times n factorial, and you just do it again. Okay, it's fine if you just square both of those pieces, but this is more fun because you get to cancel more stuff out. Okay, and then you multiply by the reciprocal of that one. And the -1 piece I left off, I think I forgot an n there, but you can leave it off because it's in the absolute value, so negative doesn't matter. And then you get to cancel. That looking right so far? So I'm going to write what's left here. Okay, so I've got 1 over, I'm leaving the x squared for the back, kind of like I did on this one here. So I've got 1 over 4 times n plus 1 squared. Yep, I'm going to leave that for the back, kind of like I did here. That way I'm just doing the limit with the ends, and then I've got that x piece in the back still in the absolute value. Okay, what is this piece going to equal? 0, right? So if this equals 0, isn't that always less than 1? Does it matter what the x value is? No. So this would have a domain or an answer if we're doing our, multiple choice thing of all real numbers.
The R with 2 lines.
Yeah, my handwriting's just nice, so I like to write as much as I can. So, yeah. Here, this one would be like crazy if you had to check endpoints, so it's nice that this one came out to all real numbers. And it might not even be that crazy, but it seems like it would, Yeah. Any questions on that? It's not really as bad as it looks, but it looks so impressive when you do these problems, so it's like a fun one to do, I think. Yeah, this has a lot of words, but let's just focus on the important stuff. Okay, so theorem for a given power series, there are only 3 possibilities. Okay, it either converges when x equals a, it converges for all x, which we just saw, or there's some positive number where it converges. So we have the case of this one where it converges when x is a certain value. We have the case of this one where it converges all of the time, or we have this case where it converges some of the time. Okay, if it converges some of the time, R is called the radius of convergence. So that's this piece over here. What I do is I think of this interval as like a diameter, and then I split it in half to find what the radius is. So what would be the diameter of convergence? That's not actually a thing, so don't write that on your AP test. Just say it in your head. Okay, it's 2. And so what would the radius be? 1. And do you see how right above there it says the absolute value of x minus 3 is less than 1? Okay, so your radius of convergence can always be seen right here, which is what it says in this rule. But I don't know. I feel better about making sure that this is, it's half of what this width is there. No. That's a good question, though. Yeah, let me do an example where it's not. Okay, with stuff like this, it's kind of going to fall into that, but sometimes it might not just be an x, and that's why I always look at my answer to find it, because that's kind of misleading, okay? Because if you look here, you see how it's always x in the front? If it said like a third of x, then you would have to solve it first anyway, to get that, so it would just be x. So that's why I just look at what the interval is, and then I do half of what the width of that interval is. Okay, so this one here, it says find the radius of convergence. So let's go ahead and start our ratio test. So we should be getting to the point of being able to maybe skip a couple steps here. I'm going to start with my limit as we go to infinity. And I'm going to do the n plus 1 first. So if I do n plus 1 here, that's going to be negative 3 to the n times negative 3 to the 1, right? X to the n is going to change into x to the n times x. And the denominator is going to turn into square root of n plus 2. Everyone okay with that? Then multiply by the reciprocal of what's in there. Now the negative 3 is going to just turn into 3, isn't it, if I take it out of that absolute value? The only thing I like to keep in the absolute value are the x's. So just be careful that you don't end up with a negative. So negative turns into just 3. And then I've got the square root of n plus 1 over square root of n plus 2. And then in the back, I've still got absolute value of x. What is the limit going to equal here? 3. So I've got 3 absolute value of x, and that has to be less than 1. Okay, so moving to our next step, I would want to get that absolute value of x by itself, so I would divide by 3. So now I have absolute value of x is less than 1/3. So that would mean x is between negative 1/3 and 1/3. So what is the radius of convergence? 1/3. Okay, which you can see here, but I always look at this and just make sure I didn't mess something up with my thought process there, because some people like to look back here and say, oh, it's 1. You actually have to have that x without a coefficient out front. Okay, so find the radius of convergence and the interval. So am I guaranteed that I have the right interval here? No, because what do I have to do?
You gotta test your end.
Test your endpoint. So I'm going to give you a 2-minute head start. Go. Okay, so if we're testing x equals 1/3, that's the one you guys were just doing, right? So we've got n equals 0 up to infinity. And if we plug 1/3 in for the x, this becomes 1/3 to the n times negative 3 to the n, so we get negative 1 to the n. And then it's over this. So if we do the alternating series test, our b sub n is this. And our b sub n plus 1 is this. So the denominator is bigger here, making it smaller. So part I, our b sub n plus 1 is less than or equal to b sub n. That's one of the pieces you need. And then double I, you take the limit as n goes to infinity of our b sub n. I'll just write b sub n to save space. As we go to infinity, that goes to 0. So what does that tell us? Convergence. So if it converges, we want to include it, right? Okay, the other test, x is negative 1/3. So this would turn into 1 to the n, so it'd just be 1 over square root of n plus 1.
Comparison test is 1 over root n.
Okay. Okay, so you guys, because I used an integral test, but we can do a different test here, so let's try it. So which test we're using? Comparison test?
Comparison is 1 over square root n. That's bigger. Oh wait, shoot.
Is it inconclusive now?
No, it's smaller. Yeah, it's smaller.
We're good? Okay.
Since 1 over root n is bigger, that means
Okay, so hold up. So the denominator here is bigger, making a sub n less than or equal to b sub n. Okay, now if I did the series of that one, a p series, our p is equal to 1/2. So what happens if p is 1/2? Diverges. So if this one, if the bigger one diverges, does the smaller one have to?
No.
No. So that's inconclusive. So we'd have to do, I don't know that we'd have to do an integral test, but we can do an integral test here. Did that work?
I don't know.
Okay. So limit comparison test, we'll just do it here. I can't do this stuff in my head. It just doesn't work. Okay, so limit comparison test, we take the limit. Our a sub n is this. And instead of dividing by b sub n, we're going to multiply by this. That seem okay? So we get the square root of n over, whoops, I forgot my limit there. Limit. That looks nice, right? That's what that says, limit as n goes to infinity. So as we go to infinity, what is that going to turn into? 1. And c has to be greater than 0, so it is, right? So either both converge or both diverge, and we know that b sub n does what? Diverges. So if b sub n diverges, then we know that this one has to diverge. So diverges by the limit comparison test. So then we don't include that one. See how fun these are, guys? See how well you have to know your test, though, to be able to do a bunch of that stuff? Okay. We'll do the last page tomorrow, so I will get you guys the homework here. It's underneath that puppy. So 3 to 27 every other odd is what's required. That doesn't mean you can't do more if you just feel the need. And I'll send you guys the answer key later today. But tomorrow we'll finish the notes. We'll have some time to work on it too. So